We'll take a look at random sums, the area approximations. They're from different directions, but first we're going to look at is from the right, which is also known as the upper sum or circumscribed. So either one of those three words they're going to use when asking you the question. It just means using the right hand side of the rectangle for your height. Alright, so integration can be used to find the antiderivative, which you already know how to do, but it can also be used to find the area under the curve. Now, I already introduced you to this concept at the very beginning when we first started integration. So now we're actually going to expand on that. We're going to dive a little bit deeper into it. Alright, so let's take an example. Find the area under the curve of the function y equals x squared plus 2 from x equals 1 to x equals 3. This is a listening check. Put a triangle around example. Alright, so the very first thing that you're going to do is draw a graph representation of what's happening. So let's go ahead and draw that. Well, this function looks like the parent is x squared. Now what are we going to do to it? We're going to move it up 2, because that's what the plus 2 means. So we're going to move x squared up 2, and that's going to give us the x squared plus 2. Alright, now that we have that, it's not the entire curve, it's only from x equals 1 to x equals 3. So from x equals 1 to x equals 3. So at 1, if you plug in 1 to the function, you'll get 1 squared plus 2, which is 3. So when x is equal to 1, y is equal to 3. And when x is equal to 3, y is equal to 3 squared is 9 plus 2, which is 11. Right, so I'm only looking at that section. So they're trying to find the area underneath that curve. Well, one of the ways that we can find the area, like we had done before, is by drawing rectangles. Now we're drawing rectangles from the right hand side. So from the right hand side we draw a rectangle, and we can find the area of a rectangle because it's space times height. But notice that the area will have so much error in it. So let's see what would happen if we split it in two. Now, to remember how to do this, because sometimes it gets with fractions, there's a little saying that I remember. It goes midpoint, midpoint, what do? Add them together and divide by 2. Midpoint, midpoint, what do? Add them together and divide by 2. Alright, so to find the middle, basically, you add the two numbers on the outside and divide by 2. So 1 plus 3 is 4, divided by 2 is 2. So now we have two rectangles. Now, because we're doing this from the right, you're drawing a rectangle from the right hand side. But you can see that we're still going to have an error. So what I can do even more is split each of those two rectangles into two more rectangles. Because you see, I'm shading how much error we're going to have because we're going to have an overestimate basically. So if we split up into 4, I'm just going to draw the whole thing again. This is a listening check. Underline midpoint, midpoint. Alright, so split it back into 2, so 1, 2, and 3. And then half of that will be 1 plus 2 is 3 divided by 2 is 3 over 2. And then half of this other one will be 2 plus 3, which is 5 divided by 2, which is 5 over 2. Now we have 4 rectangles. And again, starting from the right-hand side, okay? Starting from the right-hand side, we can make our rectangles. Alright, so step 2 would be split the bases of the rectangles equally. It just makes it so much easier. Some questions will have done this for you, but unequally. And we'll go over that case later because it's just one step difference. Right, then step 3 would be, what is the value of each base? What is the value of each base? So if you look at it, the difference between each of those bases is just a half. Every single one is a half because I split it equally. It makes life so much easier. So the base of every rectangle is a half in this case. Right, number 4 would be plug in the x values of the right side of each rectangle, because this is the right approximation. So the right side of each rectangle into the function to find the height. And I'm abbreviated rectangle with the shape of a rectangle because I don't feel like writing it all out. This is a listening check. Circle the number 4. Step 4, circle 4. The number of rectangles should be the number of heights. It's just to kind of make sure that you don't do too many. The number of rectangles should be the number of heights. Alright, so from the right, So I start on the right and I draw a rectangle. So you can see it'll be an over estimation. Start from the right, draw a rectangle. Start from the right, draw a rectangle. You start from the right, go to the curve, and then you draw a rectangle. Alright, so you can see that my area is going to be a little bit less, right? So I'll get a bigger number than the actual area, but it'll be smaller. Smaller than at least the first example, because you see that that's a lot of space. So it's getting smaller and smaller, and the more rectangles you have, the even smaller the area is. Alright, and then finally, step 5 would be to find the area of each rectangle and add them together. Find the area of each rectangle and add them together. So the area of a rectangle is base times height. Alright, so let's go ahead and do this example. So step 1, we've gone ahead and drawn the graph representation. We've split the boxes. So now we need to find the value for each base. Well, each of the bases is a half because we split it evenly, right? So it's all a half. And then after the base, it says plug the x values into the right side of each triangle, the right hand side. So every right hand side, we're going to plug it in and find out what our y values are. So we should have 4 values. So I'm going to label rectangle 1, rectangle 2, rectangle 3, rectangle 4 so that you just know what I'm talking about. So starting with rectangle 1, the right hand value of rectangle 1 is 3 over 2. So we need to find f of 3 over 2. In other words, what is my y value when my x value is 3 over 2? That will give me the height of the rectangle. So it'll give me the height of the rectangle. So my y value when x is 3 over 2 is just plugging it in to x squared plus 2 is going to be 3 over 2 squared is 9 over 4 plus 2. We'll make the denominators the same. Do it at the bottom, do it at the top. Then go ahead and combine them because now they're the same denominator. So it's 9 plus 8, which is 17 over 4. Second rectangle, the right-hand side value. The right-hand side value is 2. So plug 2 in. So 2 squared is 4 plus 2 is 6. The third rectangle, the right-hand side value is 5 over 2. So plug that in. 5 over 2 squared is 25 over 4 plus 2. Make the denominators the same. So multiply top and bottom by 4. So you're going to get 33 over 4. Fourth rectangle. The right hand side value is 3. So plug 3 in. So you're going to get 3 squared, which is 9, plus 2, which is equal to 11. And I know it cut off, but you know, when it goes up, you can see it or you could just hear what I was saying. Alright, so after that, you find the area of each rectangle. So now we have the base and we have the height. So you just find the area of each rectangle, base times height for each one. So the first one, or the total area, is going to be the area for a rectangle 1 plus the area for rectangle 2 plus the area of rectangle 3 plus the area of the rectangle 4. So when you add all those areas up, you're going to find the total area. One way to represent that is a sigma notation, and it says it goes from 1 rectangle to 4 rectangles. So it starts from I equals 1, or 1 rectangle, ends at 4, and then Ri, which would mean the area of the rectangle. It's called sigma notation. It just represents the sum. So instead of us saying, you know, rectangle 1 plus rectangle 2 plus rectangle 3, it would be understood that it's plus. This is a listening check. Color in total area. Color in total area. So the area of the first rectangle plus area of the second plus area of the third plus area of the fourth. Right, so let's do that. Base times height, right? All the bases are half. So it's going to be a half times the height for the first rectangle. The height for the first rectangle is 17 over 4. So 1/2 times 17 over 4. And then plus, I guess I should just label that's the height just so that you can keep track of it. Plus base times height for the second rectangle, which is going to be a half again, and the height for the second rectangle is 6, plus the base is a half again. The height of the third rectangle is 33 over 4, plus the fourth one, which is a half, times the height of the fourth one, which is 11. Notice all of them have a half, so I can factor out a half because everything is multiplied by half, and that will leave me all of these heights added together. So 17 over 4 plus 6 plus 33 over 4 plus 11. Now to combine those, I need to make the denominators the same. So we're going to make all the denominators 4. If I do it at the bottom, do it at the top. And that's going to give me 1/2 times, and that's going to be 17 because it stays the same. That's going to be 24 plus 33 plus 44 all over 4. Go ahead and add all of those together. So if you add the numerators together, you're going to get 118 over 4 multiply the two fractions. So remember, multiply numerator, which is 118, multiply denominator, which is 8. Go ahead and simplify. So if I simplify by 2, I'm going to get 59 over 4. Which if you punch that in a calculator or long divide, you're going to get 14.75. So I know that this is an overestimation of the area, but it's going to get us pretty close. All right, so we're going to take a look at the left-hand side in the next video. Let's practice.